This is the last lesson of the school year. We are going to do the hypothesis test, and this is one of the most important portion of inferential statistics. There is some similarity with the confidence interval, but it's a little bit more different because we're actually testing, whereas confidence interval gives you just an interval. So sometimes people prefer confidence interval because it gives you a little more detail, whereas hypothesis test usually just give you a result. So in a hypothesis test, we have three things before we have to set it up before we can start the test. So the first thing is something called the null hypothesis. It is written as a H0, which is basically what people are claiming. But in this class, and also if you take AP Statistics next year, the only claim that they're making is that some value, either mu or the population proportion is equal to a number. That is always going to be what your null hypothesis. An alternative hypothesis is basically what you want to kind of like test against. So you want to gather evidence to say that alternative hypothesis is more likely than the null hypothesis. So interesting enough, this test, because of how it is set up, that you can never say that null hypothesis is true. So it's almost so the word that we use is to make a conclusion is that we either reject the null hypothesis or we fail to reject the null hypothesis. So there is nothing about the null hypothesis being actually true. It's just that we don't have enough evidence at this moment to say that the null hypothesis is not true, but we can't say it is true because that's not what we are testing for. So understanding that concept is actually very important because statistics is a very powerful tool, but it's also very limited because of how we set things up. Sometimes people want to make like a conclusion that isn't really directly related to what we're testing, and we're very guilty of that. And so studying the statistics really gave you an objective view. What is it that we are actually testing? What can we say out of this result? So know that in any of the hypotheses that we are going to learn, we can't never say that the result of the hypothesis test is that null hypothesis is true. Okay. So let's look at an example, because first you need to learn how to write each hypothesis before we can do the testing. So the hypothesis, if you think about it, we want to make an inference about the population, right? So the statistic, so the value you're going to use is always a parameter, which is the statistic value for the population, right? So let's read A. It says, a doctor claims that the pulse rate of a patient changes from 82 beats per minute after taking a new medication. Okay, so it sounds like what they're claiming is that the mu, which is, so we need to define what mu is first. So the mu is the true mean or the population mean of the pulse rate of a patient. Okay, and basically what we want to test is that, is this 82, or as the doctor claims, is it not 82? Right? Because doctor is saying that this medication is changing the beats, average beats per minute, but he doesn't indicate whether it changes positively or negatively. So since he doesn't give us any direction of how the number is changing, the only option we have is the not equal to. So the alternative hypothesis can have less than equal to, not less than, greater than, or not equal to. And null hypothesis for this course, you're only going to use the equal sign. Okay, so if you read the question and if you feel like someone is claiming something is more or less than, still write the null hypothesis as a some number equal to something, and then change your alternative hypothesis based on what you're reading. So the very first thing you need to do is defining the variable that you're writing, okay? So let's look at number 1 and look at another example here. So on a scale of 1 to 10, patients describe their anxiety levels as 8 during dental procedures. So mu, I can define it as a true mean. The reason I put true is because I need to emphasize this is a parameter, not just a statistic, okay? True mean anxiety level that the patients experience during the dental procedure. So I need to be very specific because I can only test a very specific settings. So then the null hypothesis would be that they are experiencing at 8, okay? But then the dental assistant thinks that when you play in soft music, it will be lower than 8. That's why the alternative hypothesis would be the mu less than 8. I hope this is making sense. I think this is the hardest part of online teaching because with these things, I need to really know that if you're understanding and following so that I can explain a little more, but it's a little bit more tricky. All right, number 2, a real estate agent claims that the average home price is in the area is $250,000. So then the mu would be an true mean or true average home price in this area. I don't know what area it is, but in this area, okay? What they're claiming is it's $250,000. And you might ask, oh, but they're not claiming anything else. So then what you do is that not equal to that thing, okay? So you cannot say less than or greater unless it is very explicitly stated in your question. When it's not stated explicitly, you always choose not equal to. Number 3, a hiker claims that the average trail length in a park is at most 10 miles. So this one, mu is the true average or true mean trail length in this park. So the null hypothesis is something always equal to, so it's equal to 10, even though the question says at most 10, right? What that means is that this will be less than 10. That's what at most 10 means, right? Because it won't be more than 10. So the alternative hypothesis, the mu is less than 10. This one is actually a little bit tricky because it requires you to use the less than or equal to sign, but we can't actually test less than or equal to because our null hypothesis has to be equal to. That means our alternative hypothesis shouldn't include equal to. So when you are reviewing for the quiz, you're not going to see a problem like this. It will be less than 10 miles. It will be more clear wording so that you know exactly what to do. I don't know, in a more advanced statistics, you have more options, whether your null hypothesis can be less than or equal to, or greater than equal to, or not equal to. But in a high school curriculum, and also the introduction level of statistics, even in the university, they don't deal with anything more than this setup. So every null hypothesis is always equal to a number. So that's why I'm teaching it that way. And if you're more curious about how more advanced statistic works, I don't think I'm the best person to ask, but if you are really curious, I'll try to find out, okay? Number 4, a restaurant owner claims that the average age of diner in a certain area is greater than 40. So then the mu will be the true average age of diner in a certain area. This area, right? This area. So the null hypothesis would be mu is equal to 40, but alternative would be more than 40. Okay, so I hope you're at least be able to kind of write those hypotheses So once you have a hypothesis written, you actually have to carry out the test. And like everything that we have done so far in this chapter, we are going to use a calculator. So what you need to understand is that I told you that there are the 3 things that you need to set it up before you start the test. And so we looked at 2 of the 3, which is a null hypothesis and alternative hypothesis. The one thing that we didn't talk about was the significance level. So alpha, this is a Greek letter alpha, right? It indicates a significance level. What that means is like, it's almost like a confidence level. But confidence level is like how confident you want to be. And a significance level works like this. Let's say, because we are always looking at the distribution, that my null hypothesis said, well, the true mean is about like 40, okay? And then our alternative hypothesis said that true mean is greater than 40, for example, okay? So then, if my 40 is here, I don't know where my true mean is, but basically what significance level does is that it gives you an area, okay? So this is the alpha. And if so alpha level is often 0.1, 0.05, and 0.01. So you can see how it's related to confidence level because confidence level goes 90%, 95%, and 99%, right? And so what it does is that if your z value happens to be in this, so I guess this would be 0 because it would be standardized. So if your z value happens to be in this area, what you do is that you reject the null hypothesis, okay? And if your z value is not in the area of the significance level, then you fail to reject the null hypothesis, okay? And what you do eventually is not really looking at the alpha level versus your p-value, your z statistic or t statistics. We compare something called the p-value. And p-value is basically a probability. It's a conditional probability, but we didn't really go into conditional probability. So we're gonna just compare the significance level versus the z statistic. But basically what p-value is, it's a conditional probability of the alternative hypothesis happening, assuming that the null hypothesis is true. So it's a conditional probability that you already assume the null hypothesis is true, how likely it is the alternative hypothesis is also true, right? So that's why when the p-value is small, then you have more evidence that the null hypothesis really wasn't true, or you don't have enough evidence to say that the null hypothesis is true. And if the p-value is big, then you don't have enough evidence to say that null hypothesis is not true, okay? But again, p-value, we're not going to use a p-value in this class. We're going to mostly use the z statistics. So let's look at this question. Manager of a larger department store claims that the average salary for their part-time employee is $24,000. So mu is the true average salary of their part-time employees in this department store. So the null hypothesis would be mu is equal to 24,000. And they got the sample of 10, which gave them mean of this number, and the standard deviation is 1400. And it gives you an alpha value, 0.05, because those are the setups, so you have to have them before you conduct the test. And then they don't say whether they think it's greater or less than. That means that my alternative hypothesis is that it's just not equal to 24,000. Okay? So then, what we do is that we have to find the t statistics for this one because my sample size is so small, right? So we're going to find t. And how we find t is very similar to how we find z. We get our mean, and then we subtract the parameter, and then we do 1400 over square root of 10, because that is the, no, I'm getting out of time. I will make the second part of this video, and I'll continue, okay? Get your calculator.